So today we're going to be expanding the expression, the quantity 1 plus 3x times the quantity 1 plus 2x to the third power. So we have to do this in two parts. We start with the second binomial that we see that's raised to the third power. To do this, we're going to be using the binomial theorem. The binomial theorem tells us that when we have a binomial, a plus b, to any power, we can solve that as the sum from k equals 0 to n, using the binomial coefficient n choose k times a to the n minus k power times b to the k power. So what does this mean to us? For this, we have to define what is a and what is b. So first, I'm going to say a equals 1 and b equals 2x. And we are going to be going up to n, that is 3, for this expression. So first of all, we start, and we want to know what exactly is n choose k. So in each case, it's going to change for each of the terms. Since we have a binomial that's to the third power, we know that we're going to have 4 terms. So we start with the first term. We have 3 choose 0. 3 choose 0, we solve to be 1. 3 choose 1, we solve to be 3. 3 choose 2 is equal to 3. And 3 choose 3 is equal to 1. So now we can start plugging these in and solve our equation. So this will give us 1 times a to the 3 minus 0 power, so that would be 3, times b to the k, which is 0 power. B to the 0 is 1, plus the second term, which would be 3 choose 1, 3, times a to the 3 minus 1 power, so that would be a squared, times b to the first power. Plus the third term, we have 3 times a to the 3 minus 2, which is a to the first power, times b to the second power, plus the fourth term, we have 1 times a to the 0 power times b cubed. So the next step you have to do is you just have to substitute in each of the terms that we have for a and for b up above. So for every a, we substitute in 1, which in all cases we know 1 to any power is going to be 1. And the second term, b, we have 2x. We'll just have to substitute in and then multiply as it has to be. So here we start with the first term. We have 1 times b to the first power, that's 1, plus 3 times a squared, that's 1 squared, times b to the first power, b is 2x, plus the third term, we have 3 times a, which is 1, times b squared, the quantity 2x squared, plus the last term, 1 times a to the 0 power, which is 1, times b cubed, the quantity 2x cubed. So then we multiply each term. 1 times 1 times 1, 1, plus 3 times 1, 3, times 2, 6, times x, 6x, plus 3 times 1, 3, times the quantity 2x squared. So we have to square both terms in the parentheses, so we have 4x squared. 4x squared times 3 gives us 12x squared, plus our last term, 1 times the quantity 2x cubed. So we have to cube each term. We have 2 cubed, that's 8. And x cubed is x cubed. So here we have just the second binomial expanded. So to find a final solution, we have to plug this entire amount into the initial question that we have. So to solve this, we have to use the distributive property. To solve this, we start with 1 plus 3x times that expanded solution we have previously, which was 1 plus 6x plus 12x squared plus 8x cubed. So first we start with the 1, and we're going to multiply that by each term in the second expansion. So we have 1 times the quantity, 1 plus 6x plus 12x squared plus 8x cubed quantity, plus, then we have the second term, 3x, we multiply that then, times the second, 1 plus 6x plus 12x squared plus 8x cubed. So the first one, we don't even have to multiply it out because it's times 1 plus 6x plus 12x squared plus 8x cubed. Plus, then we multiply 3x times each term. We have 3x plus 3 times 6, 18, x times x, x squared, plus 3x times 12x squared. We have 3 times 12, 36, times x squared, x cubed, plus 3x times 8x cubed. So we have 3 times 8, 24, x times x cubed, that's x to the 4th power. So there we have our final solution, but we see that we have several terms that we can combine. So we start by searching for those. We have 1 plus, then we see 6x. Is there another term with an x? Yes, 3x. 6x plus 3x, 9x. Plus, the next term, we have 12x squared and another x squared, 18x squared, 12 plus 18, 30. X squared plus 8x cubed plus 36x cubed, we have 44 x cubed plus our last term, which is only 1, 24 x to the 4th power. And so there we have our final solution. Okay, so this question asks us to find the term that is independent of x in expansion of this binomial. So what does that mean exactly? It means we want to find which term is not going to have the x in the final solution. So first of all, we're going to be expanding this binomial by using the binomial theorem. So again, we remember that we have a plus b to the nth power, which is equal to the sum of k equals 0 to n, where n choose k, a to the n minus k power times b to the k. Okay, so for this, you guys, we're going to be using the first term, x squared, for a. So a equals x squared. And the second term, b equals negative 1 over 2x. And n is going to be 3. Since this is a power of 3, we already know that there are going to be 4 terms. And we are going to find what each of the n choose k is. So we'd have n choose k for each situation. We start with 3 choose 0, 3 choose 0 equals 1. 3 choose 1 that equals 3. 3 choose 2 equals 3. And 3 choose 3, that equals 1. So first of all, we are going to write this whole expansion with these numbers, the coefficients. We have 1 times a to the third power times b to the 0 power plus 3 times a squared times b to the first power plus 3 times a to the first power times b squared plus 1 times a to the 0 power times b cubed. Okay, so then we just plug in each of these variables that we have up here for a and for b. Taking note that b does have a negative, so we have to remember that that is there. So plugging that in, we have 1, which is 1, times a cubed. So a is x squared cubed times b to the 0 power, which is 1, plus 3 times a squared. So we plug in x squared times b to the first power. b is negative 1 over 2x plus 3 times a to the first power. So we have x squared to the first power, it's itself, times b, negative 1 over 2x, the quantity squared, plus 1 times a to the 0 power is 1, that's 1, times b cubed, so we have the quantity negative 1 over 2x to the third power. Okay, so then we just multiply each of those out. Here we have x squared cubed, so we have 2 times 3, that's 6, x to the 6th power, plus 3 times x squared, 2 times 2, 4, x to the 4th power, times a negative 1 over 2x. So we are going to take out that negative in front of the 3 and place the 2x underneath, which we will have to simplify later, plus 3 times x squared. And then we see the negative 1 over 2x, the quantity squared. So we have a negative times a negative, so that will remain positive, times 1 in the numerator over, we have 2x in the denominator squared. So we'd have to square the 2, that is 4. X becomes squared, x squared, which we will have to simplify. And then we continue on to the last term, just to finish this exercise. We have negative 1 cubed, so we know that this whole term would stay negative. We have 1 cubed, that's 1, over 2 cubed, 8, and we have x cubed, x cubed. So then we're going to simplify. So here in the first one, we see x to the 6th stays the same. Second term, we have negative 3 over 2. We have x to the 4th over x. So we can cancel out 1x, and then x to the 4th becomes x cubed. The third term, we see we have 3/4, and we have an x squared in the numerator and an x squared in the denominator. Those will cancel out. So we actually see our solution, but we're going to continue. Minus 1 over x cubed, we can simplify. So our final answer would be equal to x to the 6th power minus 3 x cubed, 3 halves x cubed plus 3/4 with no variable minus 1 over 8x cubed. So here we expanded this binomial and we have found the solution. So we want to answer our question now. Find the term independent of x. So we can look at this. We have the first, second, and the fourth term with x, but the third term does not. So the term that is independent of x would be 3/4. So our answer is 3/4 is independent of x.